Welcome to the EPG Padashala, the lecture series in computer science for the PG program, and this is the subject compiler design, and 16th module will discuss about the SLR parsing algorithm. And development team to learn to parse the input string based on the LR parsing table, and the keywords SLR parsers and parsing. So, this is the grammar which we already know, the same expression grammar which is an unambiguous grammar. So, this is the table which we have already constructed, okay, and this is the situation. So, the configuration will be something like this, okay. The top of the stack will be always a state number, input will be some AI. So, you will be comparing the top of the stack state number with the input AI, and depending upon that you will do a push or a pop action, okay. So, if it is shift S, you will push AI and the state S into the stack and advance the input pointer by one position. So, at any point of time the top of the stack will be having only the state number S, okay, and this is a typical configuration. So, you will start with S0, X1, S1, X2, S2, X2 etc. and up to Sm, and if the action is going to be a reduce action, you need to pop the length of beta, you have to find the length of the beta first and then pop 2 beta length symbols, and then you have to push A onto the stack, and then you have to find the previous state number comma A, that go to has to be referred in the parsing table, and that will be again a state number that is pushed back onto the stack. Now, when I pop 2 beta symbols from the stack, irrespective of the length of beta, 2 beta will be anyway even, therefore, again I will be ending up with only some state number on the stack only. So, on that particular point what do I do is I have to push A back onto the stack. What is A? A is your LHS non-terminal that is pushed onto the stack. I have to find Sm minus R of A. What is A? R here? R is the length of beta. So, I have to pop 2 R symbols. When I pop 2 R symbols, anyway I have a state and a symbol, state, symbol, state. So, that will end up in a state number which is nothing but Sm minus R. I have to push A onto the stack, and then I have to insert go to of Sm minus R comma A onto the stack, which is nothing but the state number S again. In that case, input pointer does not advance at all, okay, input pointer remains as it is. So, if Smi comma Ai is equal to accept, then you stop parsing. If Sm comma Ai is an empty entry in the table, that is going to be an error routine. So, you have to try attempting for error recovery. Again, it is going to be a panic mode of error recovery, where you will try deleting the input symbol such that there will be a match of Sm comma A in your parsing table. So, this is the parsing algorithm. Set the input pointer to the first symbol of $. Again, here again you are trying to terminate your input string with a $. Now, I have to repeat, okay, this is to be repeated. Let S be the state on the top of the stack and let A be the symbol pointed to by IP. So, S is on the stack, A is your input. So, check action of S comma A in your parsing table. If it is shift S dash, then push A and S dash on top of the stack, move input to the next input symbol. If it is reduce A comma beta, then pop 2 into beta symbols of the stack, let S dash be the state now on the top of the stack and push A, and then go to of S dash comma A is computed, which is added to the top of the stack. Okay, output the production, A produces beta. Else, if action of S comma A is equal to accept, then you return, else you basically call for an error. So, it is going to be 4 possible options. Let us consider this example. Again, example is ID into ID plus ID $. Initial stack state is going to be from at 0. Now, 0 corresponds to the initial item set I0, okay, that is what is this 0 corresponds to. Now, 0 comma ID. So, the table entry says 0 comma ID is S5. So, I shift ID onto the stack, I also shift 5 onto the stack. So, it says if go to if action of I comma A is equal to shift S dash, you shift A and then you shift S dash onto the stack. So, I have shifted now ID comma 5 onto this ID and then 5 onto the stack. Looking at 5 comma star, 5 comma star will be R6, okay, which is a reduction. So, I have to pop 2 beta symbols. Now what is F R6 production? Basically it is nothing but F produces ID. So length of beta is 1, so 2 beta is 2, so I have to pop 2 symbols from the stack. So I have to pop 5 comma ID from the stack. I have to push the LHS non-terminal, which is nothing but F onto the stack. I compute 0 comma F, go to of 0 comma F, which is nothing but 4, and I push F4 onto the stack. Next step, 4 comma star, 4 comma star is R4, okay, and R4 is nothing but T produces F. So pop again 2 symbols from the stack and insert T onto the stack, compute 0 comma T, go to of 0 comma T, which is nothing but 2. So insert 2 onto the stack. Now 2 comma star, it is nothing but a shift S10. So push star, push 10 onto the stack. 10 comma ID, again it is nothing but S5. So push ID and 5 onto the stack. Now 5 comma plus will be again reduced by 6th, which is nothing but F produces ID. So pop 2 symbols from the stack and do go to of 10 comma F, which is nothing but 11. So I have done till this step 10 comma F, which is nothing but 11. So this is the input situation now. 11 comma plus is again reduced by the third production, which is nothing but, now R3 is nothing but T produces T star F. As you could see here, there is a T, there is a star, there is an F here, okay. So I have to reduce, I have to pop, how many symbols? I have to pop 6 symbols from the stack. So 6 symbols will be 1, 2, 3, 4, 5 and 6, and you are popping till 6 symbols. Ultimately speaking, you are popping the RHS, the production from the stack, and you are pushing the LHS non-terminal onto the stack. So the RHS non-terminal here, RHS production is nothing but T star F. It is appearing between the numbers because you have anyway pushed the state number also onto the stack. That is why it has got the state numbers here. So therefore you do a 0 and T is here. So do a go to of 0 comma T, which is nothing but 2, push 2 onto the stack. Now 2 and plus, which is again reducing by R2. So that becomes E. 0 comma E is nothing but 1, that is pushed onto the stack. Then 1 comma plus, okay, 1 comma plus will be shift, okay, which is S6. So push plus and push 6 onto the stack. 6 comma ID S5, which is again a shift action, push ID and push 5. 5 comma dollar is R6. So reduce it to F and then you again reduce it to T, okay. Now 8 comma dollar is R1. So you have to pop 6 symbols from the stack because the production R1 is nothing but E produces E plus T. Again you can see that E plus T is here, okay. So you pop 6 symbols of the stack leaving you with 0 comma E. You know go to of 0 comma E is 1, that is pushed onto the stack. You know now 1 comma dollar is an accept action, which is a successful parsing. Now if you encounter some incorrect combination, you have to actually delete the input such that you are able to find out a match between the the stack and the input symbol. So till that you have to keep on deleting characters from the input sequence, or you can keep on deleting the stack till you are able to find out a matching pair. So this is the parsing action. Anything else is going to be called as an error. Now the problems with SLR grammar. So you have constructed the LR of 0 items, you have constructed the parsing table based upon the LR of 0 items, and you have also constructed the parsing action for a particular example string. And there is no conflict in this particular grammar, therefore we are fine with this. The problems with the SLR grammar are, every SLR grammar is unambiguous, but not every unambiguous grammar is SLR. So it is going to be a tricky situation. So SLR grammar will parse unambiguous grammar, but every unambiguous grammar cannot be parsed using SLR parser, okay, that is the criteria. Now consider for example the unambiguous grammar which is here, S produces L equal to R, S produces R, L produces star R, L produces ID and R produces L. Now what is this grammar actually? This grammar is an assignment here, L equal to R, where L can be a pointer or R can be a pointer, both can be a pointer assignment. So I have here star ID is equal to star ID, which is a possibility, okay. So, or I can also have star ID is equal to star ID, that is also a possibility. So, assigning pointer variables, okay, that is going to be your dereferencing a pointer and then assigning it is what we are trying to look at here. So, this grammar is unambiguous. So, but this is not going to be an SLR grammar. So, we will see how. Now, let us look at the item set construction. You have augmented the grammar S dash. So, S dash produces dot S, that is the first item. Now, I have to add the productions of S, which I have added here. S produces dot L equal to R, S produces dot R. Now, these two productions resulted in requiring you to add the productions of L and R respectively. So, L produces dot star R and L produces dot ID and R produces dot L. This is also added to the grammar. Now, I have a dot L here, but the productions of L has already been added. So, that leaves with I naught. Now, I have to find I naught comma S, I naught comma L, I naught comma R, I naught comma star and I naught comma ID. I naught comma S is very simple, S dash produces S dot, shift the dot by one position to the right, okay. And I2 will be I naught comma L, so two productions qualify. So, I have to shift S produces L dot equal to R and here I have R produces L dot, okay. There is an equal to here which is a terminal, therefore, no further productions has to be added here to I2. Now, I3 is I naught comma R, which is only one production will qualify, which is S produces R dot, and I4 will be I naught comma star, that is L produces star dot R. I am shifting dot by one position. Now, I have to add the productions of R. R has got only one production, which is R produces dot L, okay. Now, I have to add the productions of L, so which is L produces dot star R and L produces dot ID, okay. We are not yet done, I naught comma ID is pending still, which is nothing but L produces ID dot. There is nothing to add here. Then, I am done with I4, I5. Now, if you look at I1 is done. So, I2 will be what? I2 comma equal to should be added, should be computed. Go to of I2 comma equal to should be computed. So, which is nothing but here I2 comma is equal to shifting the dot by one position to the right. Now, that leaves with R, adding the productions of R as it is and then adding the productions of L as it is, okay. Now, I2 is done, there is nothing in I3, okay. Now, I4 is I4 comma R, I4 comma R, which is nothing but L produces star R dot. So, shifting the dot by one position to the right and then I4 comma L, which is nothing but R produces L dot and R I6 comma L, that is also R produces L dot. So, this I2 and I8 are not same because I2 has got this production also, okay. So, when you look at I0, I have two productions that has a L after a dot, but if I look at I4, there is only one production here which starts with a L after a dot. So, this is what is I4 comma L is, okay. So, I am done with I4. Now, L produces dot ID, that can be considered as I4 comma ID is also here, okay. And I have here I4 comma star, which is the same set, okay. And finally, I5 is done, I6 comma R, that is what I have here, I9, which is nothing but shifting the dot by one position to the right. Now, I6 comma L is the same I8, I6 comma star is the same I4, I6 comma ID is the same I5. So, this is what I have basically computed. So, this computes the item set, which is nothing but LR of 0 items. The next step is to construct the follow. So, follow of S comma L comma R. So, as you could see from this grammar, follow of L will have an equal to, okay, and follow of R will contain follow of L. Here follow of L will contain follow of R, and here follow of R will contain follow of S. So, follow of R contains follow of S, follow of L contains follow of R. So, basically I have to compute follow of L first, that gets transferred to follow of R, which is also available in follow of R contains follow of S. So, follow of L contains follow of R and follow of R contains follow of S. So, but follow of S if you start with, that is going to be having a dollar. Then follow of L will have an equal to, because of the production S produces L equal to R, and follow of R will have a dollar comma equal to, because there is a production S produces R. Okay, there is a production S produces R. Okay, so, follow of R will contain follow of S. Okay. So, I have here that also as a follow here. So, dollar will be there in follow of L and follow of R will contain also dollar comma equal to. So, this is what is my follow set. After computing the follow set, now it is time to compute the parsing table. The parsing table, as you could see, I0 comma ID, okay, it has L produces ID as a production. So, that basically went to S5. So, that basically went to the item number 5. So, I have S5 here. I0 comma star is I4. So, I have S4 here. I0 comma S is 1, I0 comma L is 2, I0 comma R is 3. So, these 5 entries here in the first row correspond to the item number referring to I0. Okay. So, I0 comma S is I1, I0 comma L is I2, I0 comma R is I3, I0 comma star is I4, which is also I6 comma star, we will come back to that. I0 comma ID is 5, I6 comma ID is also I5. So, that is what I have shown here as the entries, and the first item number has a production S dash produces S dot. So, at the intersection of S dash I1, 1 and dollar, I have to check the accept action here. Similarly, at the second I2 comma is equal to goes to S6, okay, I2 comma equal to goes to S6, and I4 comma star is S7, I4 comma L is 8, I6 comma ID is S5, I6 comma star is S4, I6 comma L is 8, I6 comma R is 9. Similarly, I have the other 2 states, I7, okay, these are reduce action only, we will come back to the shift. So, shift is over. If we come to the reduce action, item number I2, okay, item number I2 has got this production, R produces L dot. So, I should look at the follow of R, okay. So, here if you look at this particular production, L produces star R, follow of R contains follow of L, okay. So, that is why when L had equal to and dollar, we had to consider everything, the follow set of L and the follow set of R are exactly same. So, looking at this particular production, follow of R contains follow of S. So, follow of R will have a dollar. Looking at this production, follow of R contains follow of L. So, which is follow of R will contain a equal to. So, follow of R now has an equal to and dollar from the productions 2 and 3 respectively. So, R produces dot L is there. This will say follow of L will contain follow of R. So, which has got also a equal to dollar is available here also. Now, look at this I2. So, I should look at the follow of R which happens to be equal to and dollar. So, the intersection of 2 and equal to and 2 and dollar, I need to say reduce it by the R fifth production, which is R produces L. Okay. So, there is actually a conflict here. All other entries are no conflict. 3 comma dollar is R2, which is very simple. 5 comma equal to is R4, 5 comma dollar is R4, and the other entries are also very simple in the sense that 7 comma equal to is R3, 7 comma dollar is R3, 8 comma equal to is R5, 8 comma dollar is R5, 9 comma dollar is R1. So, again if you look at this particular table, it has got 5 and 16, 19, 22, 23 entries, but only 22 fields have been filled. But this is a table which has got around 7 columns and 10 rows, which is 70. So, again less than 50% is getting filled. The remaining combination is going to be all error entries. Okay. In addition to the error entries, there is actually a shift reduce conflict here. That is, if I see 2 in the stack and if I see an equal to in my input, will I do a shift action or will I do a reduce action? Okay, it is a conflict. Will I do a shift action or will I do a reduce action? So, shifting means I have to shift the equal to and I have to shift the state number 6 onto the stack. Reduce means I have to reduce it by R produces L. So, will I do a shift or a reduce action is going to be a question mark here. This is because I am looking at the follow character, I am looking at the follow of R for doing this table entry. Okay, that is the reason behind this parser having multiple entries here. So, I have looked at follow of R, which is nothing but equal to $1 for computing this R5 here, for having a entry here as R5. I am not overwriting it, I am simply having additional field here. So, S6 comma R5 basically tells you that I can shift or I can reduce, but which one will I follow, I do not know. The parser will be confused. Normally, when I have a shift or a reduce conflict, you normally go with the shift as a way to resolve it. But this is not the solution. Sometimes you might end up in an error also. So, this is a criteria, and this grammar being an unambiguous grammar, even then the parser is unable to handle this situation. Okay. If you remember that the parser cannot handle this because the follow is considered for filling up the reduce action. Okay. So, that is the drawback of this SLR parser. So, the conflict is a shift or a reduce conflict arises here, and the shift or reduce conflict, and that is the reason why we call this grammar as not a SLR of 1 grammar. So, the previous condition where the expression grammar you had E produces, I mean the expression grammar, unambiguous grammar actually, and that did not have a conflict, whereas here this grammar is not is an unambiguous grammar, but still you have a conflict here. Therefore, this grammar cannot be parsed using an SLR of 1 parser. Okay. So, can I say that all, so that justifies that all SLR of 1 grammars are unambiguous, but all unambiguous grammar are not SLR of 1. Follow information alone is not sufficient. That leads you to what is called as the next type of parser, which is nothing but LALR or the canonical LR parser. So, to summarize this module, so we learned to parse the SLR of 1 parser grammar using the SLR of 1 parsing algorithm, and some grammar results in a shift reduce conflict. The grammar can be unambiguous, but the parser cannot handle it because of the shift reduce conflict, because the SLR of 1 parser uses the follow information. The follow information is not sufficient to handle some grammar. So, therefore, that is a conflict. That is what we have basically seen in this particular module. So, thank you.